What we have here is a Sony PVM with just some really bad colors. Let me turn the volume down there on Mario. No, that is not some kind of trick from video editing. The color really is that bad. Let me show you a test pattern so you can get a better idea of how it's looking. Okay, this is a good showing of what's happening. We have an extremely high concentration of green on the screen, and the blue and red are really low. Now I've attempted to adjust the sub-menu and the color drives within this CRT and this monitor. It lets you do that, but even with everything maxed out and the green turned all the way down, we still have this discoloration. And this ultimately affects the white balance, where you can see it has a hue of everything being slightly green. Now it would be nice if we could reduce that green and kind of bring it level to the other colors and then maybe increase the overall brightness. But since that's not the case, as we increase the brightness, we're actually getting green in the background of our image too. So green is truly bleeding through on the image. And so what I need to do now is check out behind the monitor, and we're going to need to look at some things and do some tests. Right, all the boards inside this monitor have been restored and checked out, and there's no issues with any of the boards. They're all doing exactly what they're supposed to. So this leads me to believe that we need to test our actual cathode ray tube here, and thankfully Sony did such a great job with these screen printings on these old boards, because this C board actually tells us the pinout to this CRT, so we can hook up a CRT tester to this and get some readings on the condition of the CRT tube. So I'm going to connect a tool to test the tube here, and we'll go from there. All right, if you've watched my channel any length of time, you may have seen this device before. This is my B&K 467 Restorer and Analyzer from B&K Precision. Now this tool is quite old, but I've completely restored it, and I've calibrated it and checked it for accuracy, and it is in good shape as far as functionality is concerned. Now thankfully you can find the manual for this pretty easily online, and there's a lot of information about this particular device, how to use it, and how to get started with it on the CRT database, and I will link some of that information in the description of this video. Now what I use is this, which is another thing that I made with the help of the CRT database guide, and this is a homemade universal adapter, meaning I can use the pins from these to connect to any CRT I need to and run the test. And then again, the tests are described in the manual. So we can run a test to check the quality of the emissions that's coming out of the CRT gun for each color, and we'll also be able to see if there are some shorts possibly in the tube. But that can be done by connecting each one of these probes and then running the test. So I'm going to set up and connect the probes, and then we'll set up and run through the test and see what the condition of the tube is with this B&K 467. All right, I have connected my custom adapter here, and it's pretty simple to see which ones are red, green, and blue, and those are connected up top. The very top one is green, and then we have a blank spot over there, which is an additional G1, and then we have H2 and H1, and then G2 and G1 right here, and then there's a couple of like earth or ground pins, and this is a calibration pin, so that's why it's yellow, you leave it out. And that's connected here, which runs up to the B&K 467, which is plugged in and is ready to test. And just again, so you can see that this is the top point right here on the pin 11 on the tube. KG means color green, color blue, color red, red, green, blue. And then you kind of fall in line from there. And you could see pin 6 is G1, pin 5 is G2, pin 7 is H1, H2, and that's all we're using are the three colors, the two H's and the two G's. And I know it's weird because the G's are reversed as the H's and the 2's. And anyway, there we have all that set up. Now this test for Trinitrons is pretty simple. We're going to go ahead and do it right now. It's plugged in. I want to make sure this is set at 4 to 7 for our heater range. And you can't even see my buttons anymore. But there we go. We got power now connected. Power lights on. Our heater voltage needs to be 6.3. So let's get a little closer over here and calibrate that. So I can do that by turning this dial that sets my heater voltage. And as I increase it, I get right between the 6 and the 3 right there. Over here needs to be set on 50. So you can control the G1 again with this one. This one needs to be on 50 most of the time. So it's always pretty much set on 50. And then this over here just tells me my line volts, which is right at 120. That's normal here for AC current. So that's it. Now it's set up. Now if we were going to have some kind of short, we may see these lights show up. Don't really see anything in there right now. So now we'll do the set cutoffs, which is simple. Now we're going to go in here and we're going to set for the test. So you see how these are all reading in bad. So each one of these has a color wheel that I'm going to turn, and I need to get this to that first tick mark right above the 0. So right now it's on 0. So I need to get all three of them right there. Let's do that with the green and the blue. And this is just the baseline so that when we actually run the test, it'll be ready. So as we do this, let me turn the lights down in the shop, and hopefully we'll see some light. Yep, you can see where the voltage is being sent in. That low voltage is being sent in and actually engaging the CRT right there in the electron gun, and that's how it's getting the readings here. So as I turn this, it should give us our readings, because I'm going to be turning it from the setup to the test mode, and this is going to immediately test all three guns, or all three colors on the gun. And there we go. Let me turn the lights back on. We'll leave it in test mode. And wow, yeah, whew, you could see this tube is really about done. You see that? So the green, which we had seen was a bit higher, it's actually reading the highest, but it's in the yellow zone. This is a little lower, the blue and the yellow, but the red is barely in the yellow. So that's the reason the tube is not actually going to show. Let me see if these shorts are blinking. I don't see anything there. That's the reason the tube looks like such bumpkus, is we can't get it to balance out right because of all this buildup inside the CRT gun, most likely. But the 467 here has been known to work some miracles, and I've been given the authorization to try to make a miracle happen with this tube by the customer. So I'm going to safely set this up to actually run the next step in this procedure, which will try to be to clean and balance the electron gun and remove some of the buildup that's been on there from years of usage, and hopefully we can get better test results than this. And we're going to go get things set up for that real quick. First off, you'll notice I've changed some things on our monitor. I've removed all the boards except for this little board right here. That's fine. And I'm going to rehook up my adapter to the pins again. But before I do that, the reason I have it changed over here and the orientation changed up is, let me explain a little bit first. So this the cleaning, balancing, and rejuvenating. And you can read all this in the manual, but basically there's two modes of rejuvenation. The lesser strength one, which is the clean and balance, and then the full rejuvenation process. Now, with a Trinitron, I've honestly never done the rejuvenation process because the clean and balance is really enough usually to either fix your problem or blow the tube up. And so I've never even gone to the rejuvenate section, honestly. So what we're going to do is we're going to run through this clean and balance. But what it does is it uses, it says low energy restoring operation. Basically, it burns up or it heats up each color on the electron gun in there. And it's meant to burn off any kind of oxidation or buildup on those colors in each gun right in there. Or the individual gun on a Trinitron, but each color line within that gun. And then you point it down like this, because if that debris does break off, you don't want a piece to break off and then short out against the inside of the CRT gun and cause more troubles and give you an actual short. So this way, if anything does break off, it basically falls off into the front of the tube, and then hopefully when you turn it over, it kind of shuffles down to the bottom. If there is some kind of debris and you don't see it, it doesn't bother anything. So that's one of the big reasons, at least I believe, that we face it down like this. Anyway, I'm going to hook it up, and then I'm going to go through the process here of warming up the machine again, and then we'll do a clean and balance on this tube. I'm going to cut the machine on. Well, power on. All right, I want the G2 to be normal. And going back, setting up everything like we had it set for the test. 6.3, 50 volts. Line voltage is good. There we go. And there's our test. Still looking bad, right? So now we can run over, it says, and do the clean and balance. So we need to switch this to restore. And you can hear it getting higher, and you can see that got a lot brighter. And the process here is to let this warm up for 30 seconds. And then what I need to do is I need to just press this button, and this button, and this button. They're each individually colored. And so I have to press it. The meter should jump up here and then hold for a second, and then it should start to fall back, and I have to release it before it hits this 0.2. You can't really see the point there, but it's the number 2 in the bad zone, right in the middle of the bad. I need to release that color. Now when it does that, it's going to be inside here sparking around. You'll see some sparks going on. And maybe the best way I can do this is as I press the button, I'm going to set the camera down, and I may even turn out the lights if that makes any difference and helps with this demonstration. But let's go ahead now, and for the first test we'll go like this, and then you can actually see me in the background perform the test on the red first. Actually, we'll do the red last. I think the red needs to be done last, generally speaking. I'm not really sure if it matters, but we'll do the red last. So let's just do green now. It's been 30 seconds. Holding it down. It's not really jumped up. And that's it. Like, it pretty much jumped up a little bit. It didn't even get to the yellow. I'm going to do the blue now. And this time I'm going to turn the lights out in the shop. And we'll see how that looks. Okay. Again, I don't want to do this too crazy hard. I'm trying not to damage the tube. if I do damage the tube, generally a light will start blinking down here on the meter saying there's a short. So that's blue, that's green. Let's go ahead now and do the red one too, and then we'll switch back over and run a test. Okay, I'm going to run the test now, so I'm going to click the lights back on, and hopefully nothing went too badly. We're going to go back to set things up again. And here we are. I'm going to set the cutoff line again. Oh, that's not good. Our green is not responding. That's not good. So, I don't know. Our green really didn't respond good at all. Let's see if basically I can reset the machine and run a test. I'll see if I can run a test and get this going back, but we may have just lost our green. I repeated the process of the clean and balance on the green and the red gun another time off camera, and it appears that it just needed a little bit more time to do its thing. It says in the manual you may need to do it more than once. So I did get a good clip while I was doing the red that you might have seen, where you could see when the color on the gun dims all the way and then it starts to spark a bit. That's really what needs to happen, but you can't do it too much to where it shorts out and burns out the whole color. So that's the trick here. So let's go and see the results from the final clean and balance. All right, I actually repeated the process again on green and then on red. And you can tell I've gotten them both up into the good. The worst one on here is the blue, but they're all up in green in the good zone now. And this is literally a regular test. I don't see any lamps lit up for shorts. And so hopefully nothing is wrong there. What we're going to do now is we're going to do two of these other tests. There's a tracking and a life test that you could do here, and you really only do this if you actually have a green tube. And so first off, let's go back and see how we perform this. It says here that we can actually do the life test, and then after the life test is done, we can just keep holding down the life button and press the tracking button, and it'll do the tracking test. And this should just tell us, like, the longer this holds up in these areas, the longer or the better condition the guns are in now, or the gun is, and the color. So I'm holding down the life button, and you can see it's holding where it's at, which is really a good sign. And it's not really, I mean, it's starting to drop on the blue. Let's see. Okay, the tracking is not as good, right? The tracking test is not so great, but that's okay. That's okay. I mean, you can see our needles are jumping back up here. So now what we need to do is just remove everything and put the boards back in here and see if we have a better looking tube now that our tube actually tests out all good. All right, we're back together and we're set up with red, green, blue, sync and audio coming over to our Super Famicom. And I'm going to turn the power on to the Super Famicom first, just to make sure I have some power. All right, we're going to turn this on. Now, I have done this before and I've had a big pop happen, and it'll scare the dickens out of you, but it doesn't really mean anything. But I have had it after doing a rejuvenation where we get a big pop sound. So let's see if that happens. If it does, it's going to scare me. Otherwise, I've got my contrast and brightness pretty much all the way down, just in case the colors, you know, I've got them all messed up in the settings, so hopefully the balancing of the tube will help me. I'll have to readjust it, but let's just see if it works and see if it pops. Okay, no big violent pop or anything. We got red, green, and blue. Wow. All right. Let it sit here and get stable for a minute, but I can already tell that's way, way, way better than it looked before. I'm going to go and try not to make a mistake here by reaching that over the monitor. Let's go into the 240p test suite. And again, this is with everything turned all the way down. Let's go to this color bars. Oh yeah. So if you remember, hang on, get back on their scrolling image. So you can see we've still got red. So the blue's too high, the red's too low, and then everything overall needs to be increased. So as I brighten it up, it should all increase. And, oh yeah, see? So if you set it like there, it actually looks really great. Wow. So I definitely need to come in here and do some color adjustments. I'm going to let it run for a while, make sure that it has no problems. But, I mean, it looks to have been successful. I don't want to, you know, jinx anything. So, again, I'm going to let it run for about an hour, and then I'll come and make some adjustments, and then we'll check back in with it. I've been letting it run here for about 20 minutes, maybe even a little longer. Color looks great. It's not dimming or anything. I did have one little thing where it did like a screen flicker randomly, and that's not surprising, especially within the first 30 minutes. I guess that it did it now as opposed to when I powered it on. The big risk here is that heating up the cathode again, there's still some debris in there around it, and then maybe that debris gets so hot it finally does fall off one of the three colors and shorts out against something. And so that's the real risk now, is we're just going to like let this run for a while. Hopefully nothing like that happens. But that can happen, right? So that would be the thing that would cause a short, is if like maybe some piece of debris that was built up on one of the cathodes kind of slips off and hits the ground, or it, you know, shorts out two colors together, then we would have a problem. But so far it's been good and been stable. I'm going to let it run for a while because I don't really like to, you know, say it's good and gone or good and done unless it's just solid for a good hour, hour and a half. So I'll keep monitoring it, and we'll come back and look at it again at the end after that process is done. All right, it's been a little while since I've done all my adjustments, and I've got the shell back on here for the first time. I'm going to run a quick power up, and we'll see if it does anything funny. Generally speaking, if it's going to do something funny, it's got to be right after I put the shell on. I did change it to the other input. Completely normal so far. Okay. There we go. Okay. Well, everything seems to be working great. No issues. All right, so the BK467 truly did work a miracle with this PVM. We got to get a lot more color, robust picture out of it. And you could even tell from that little life test that the colors were not going to just fade away. I let the CRT run for a couple hours and didn't see a single issue as far as like the tube color changing or anything really looking different. There was the one spark that I mentioned, but I never was able to capture that on film because it happened about 25 minutes into it running, and it never happened again. So anyway, the idea here is that this tube was beyond the point of adjustment, where we couldn't really make any adjustment using the hardware built into the monitor to improve the picture quality. We were locked in at that ugly purple hue-ish off-color white balance that just really made everything a bad experience. And so, thankfully, the BK467 did its job here and actually rejuvenated this tube and cleaned and balanced that electron gun, basically burned off a lot of the emissions there, and you got to see that. But I do have to warn you that this is not a 100% thing. It doesn't always happen like this. Sometimes you end up with weird banding issues after you do this, where you might have separation of colors. You also may end up damaging the tube and having something short. That can happen when you run in, you do things beyond just the test mode of the BK467. So be mindful of that. You really should be prepared that once you do this clean and balance, or heck, even the rejuvenation process, there's a good chance that you could actually short the tube and lose it completely, and then you kind of be, in a little bit of trouble. I do want to say one last thing about the BK467. I know I'm going to probably get a lot of grief about how I'm showing off an old piece of hardware, and it's already hard enough to come by one of these things and find one. And then if you do find one, generally speaking, they are in terrible condition and they need a whole work through, makeover, redone, rebuild. And then you have to calibrate the machine, and then you have to make the adapter. So it's not an easy process. And there's an appreciation for these old tools. I'm seeing Sencors listed in Facebook groups for like $1,500, which is a different brand. You don't need those higher end ones. You can get away with a 467 like this, but this is kind of like the lowest end ones you can find. You can still find these for a couple $100 if you're really interested in getting one. The thing about these is they do things that you'll never be able to do like without it. You can't really get a true analysis of your tube 100% for sure without running the test to see if the guns are corroded or if there's any problems even to begin with. And so this does help with that and verifies a lot of things. And then obviously if you get into a situation where you need to rejuvenate a tube, it can do that too. All right, so look, thanks again for watching this video. I go through these breaks of a month where I might not post a video. I do have a couple more shots, but to be honest with you guys, my shop has just been swamped with work and CRT restorations from Patreon members. So that's really been what's happening behind the scenes as I've been just grinding through CRTs. But I always want to make I always want to take the opportunity to try to make a video and reach back out to the community, especially when it's stuff like this. There's been a lot of talk about how these CRT analyzers and testers are not supposed to be used with Trinitrons, but obviously you can use them and you can get a lot of good results out of it if you know what you're doing. I would also, again, just tell you, if you want more information, I'll refer to the CRT database down below, and you can check out more information about the CRT testers from a perspective there of CRT enthusiasts. So thanks again, everybody. I'll see you next time with some more retro content.